In the next few video sessions, we shall be talking about the different ways in which computers are classified. Computers can be classified based on their speed of performance, their size, their memory capacity, number of users, and so on. There's one more way of classifying computers based on the type of input they accept. That classification gives us a type of computers called as analog computers or digital computers, and also something called as hybrid computers, which is a combination of analog and digital computers. Now, what exactly is an analog computer? Before we head to understand what is an analog computer, let's understand what's a digital computer. A digital computer takes in data, processes the data, and produces output. The data is in binary, that means it's only in the form of ones and zeros. When data is in the form of just ones and zeros, it is referred to as a discrete type of data. Discrete means it has only fixed values. It's either 0 or 1. It is not 0.5, nor it's 1.5, nor 0.7. As opposed to that, analog computers process continuously changing physical phenomena such as electrical and mechanical signals. Now, what are example of electrical signals? It could be the voltage, it could be the current, it could be the resistance, and so on. Mechanical data could be your temperature, your pressure, your volume, and so on. So what analog computers do is they measure physical quantities like pressure, temperature, and so on, and based on that, they take a corresponding action. For example, it could be if the temperature is more than say 60 degrees, I automatically must be starting on my water sprinkler. So this is an example of an analog computer. So in an analog computer, you can see there's a lot of analog components. It's more like a electromechanical rather than a purely a digital machine. So what they do is they take this input values which happen to be resistance or pressure or something. They are taking these values, measuring them, and then they are acting on these values and producing some result. So important thing to understand is analog computers work on physical phenomena or electrical and mechanical signals like voltage, pressure, volume, and so on. Now let's try to take a look at what do we understand by digital computers. In this course, or in fact most of your life, you're almost never going to work with analog computers. These are mostly used in hospital settings or in process industries and so on. In digital computers, we process data which has only two states, either a 0 or 1. That's why you have the word called as discrete. In discrete form, the values are fixed in the sense it can either be a 0 or 1. Whereas in analog, it can have a range of values 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and so on. Digital computers differ from analog computers in the sense they are highly accurate, very fast compared to this, and they are mostly general purpose applications or general purpose computers. These are used for very specific applications, whereas these are used for highly general applications. Now, digital computers use a large number of electronic circuits. So using electronic circuits, we are able to read data, process the data, store data, which is also an electronic component. A semiconductor is an electronic component, and we are able to produce results. The advantage of digital computer is it can be used both for general applications as well as very specific applications. So digital computers or electronic computers are the only type of computers we are going to talk on this course. Analog computers is, unless you're doing a specific branch of engineering, instrumentation, you're not going to really worry about analog computers. So in your life, I doubt you'll be encountering analog computers, almost 99.9% none of you, but digital computers you'll be very frequently encountering. So you need to understand these fundamental difference. This is dealing with electrical and mechanical signals. This is dealing with zeros and ones. This is fast, highly accurate, general and special purpose. This is mostly special purpose machine. It uses electronic circuits. This uses physical components. Now, let's try to understand what exactly do we mean by a hybrid computer. The best way to understand or remember what is a hybrid computer is think of examples like an ATM or think of a patient monitoring system. Now, what is a hybrid computer? A hybrid computer is a computer which possesses the features of both a digital and an analog computer. Now, what does that mean? It means they can accept input which is both digital signals, that is zeros and ones, as well as it can accept signals like electrical and mechanical signals. Now, Since it's got features of both, there are certain devices called analog to digital and digital to analog converters. An analog to digital converter converts an analog signal like a temperature into zeros and ones, whereas a digital to analog converter converts zeros and ones into physical measurements or physical quantities for subsequent processing. So analog to digital is used for conversion from analog to digital signals. Digital to analog is used for conversion from digital to analog output. Now, hybrid computers are generally used for very specialized tasks. For example, for monitoring the patient's parameters in an ICU, or they could be used in specific process control industries. Now, let's try to understand the use of hybrid computers through its use as a patient monitoring device. Now, all of our body parameters like blood pressure, temperature, okay, these are sweat, these are all analog inputs. So these analog inputs are taken by hybrid computers, they are converted into digital signal, and then this digital signals in terms of zeros and ones are processed by this hybrid computer. So a hybrid computer takes an input which may be digital, converted into analog, or the input may be analog, converts it into digital, like in this patient monitoring system where it's converting the heartbeat, temperature, blood pressure from an analog or a physical input onto a digital values of 0 and 1. For example, a temperature of 30 degrees could be represented as 0101, something like that, and then it could use those values to do certain action. For example, in a hybrid computer, I could be measuring the blood pressure, I could be calculating the value of the blood pressure based on the body weight, height, and producing certain results and displaying it on the patient monitoring system. So far we discussed the different types of computers based on the input they process. Analog computers process changing phenomena like temperature, pressure, volume, and so on. Digital computers process data which is in terms of zeros and ones, also known as discrete data, because discrete data has just fixed values which is 0 and